alaikum. Welcome back to statistical. So today we have interpolation and regression. So let's start with interpolation. So interpolation is to predict a value within a range at given other value, and extrapolation is to predict the value beyond this range. So the objective in analysis is to use the calibration to estimate the value of y for a value of x between tabulated points. It's called interpolation, and if this value is beyond the range of the data table, so it's called extrapolation. So suppose that we have here this is curve of data, so I can predict c at given x. And if this value is beyond the curve, so this is a curve, and I want to predict c at given x, and x is beyond the x, so it's called extrapolation. Extrapolation can be used only if you can make sure that the data beyond this curve is still linear. But in analytical chemistry, most of samples drift to the right or to the left, so you can't assure that. This curve will still keep linear as you go beyond the range. So that's why extrapolation is not recommended in calibration curve and to predict the result of some samples beyond the given range. But we always use interpolation. So for interpolation, the concept of interpolation, if you want to do interpolation by your hand calculation, so the simple is that if you have triangles, you have smaller triangle and larger triangle. So the ratio between smaller part of triangle to the larger part is equal to the smaller part to the larger part. So this is the concept. So we can say y minus y1, so y minus y1, this is the smaller part divided by the larger part, y2 minus y1. Okay, so it should be equal to x minus x1, this is smaller part, smaller triangle, divided by the larger part of triangle. That's why x2, x1. Okay, so this is the two triangle. Okay, now by rearranging this equation, we can get this equation. So you can solve it by, if you just put the knowns, and then you can calculate or find the unknowns. This is by simple hand calculation. But you can use like calculator and Excel to find it quickly. So using this type of calculator, you can go for first mode and 3 to have this screen. Once you get this screen, you can choose your type of equation. So for linear, you can use this one. If it's polynomial, you can use this equation number 3. But we most of our analytical, we use only linear. So we can choose this one to number 2. So you will get this screen. So in this screen, you can put the values of x and y's based on the arrows and the data. Okay, after putting all the data, make sure you press AC to save the data into the calculator. Otherwise, the data will go away. Okay, now after that, then you want to record or want to choose the function. So press shift and 1, so you will get the screen. Now you have, if you want to do any modification to this data, choose number 2 data. But we want to find regression. Okay, regression properties. So we press 5. So 5, you will get this data. So you have A and B is the coefficient of the regression line. We'll talk about it later. And R is the correlation coefficient. Okay, but currently we are focused on Y and X. Y and X are the values to predict. So now we want to predict Y. So choose number 5. When you choose 5, you will get y screen. So just put the value you want to predict before it, okay, 2.5, the value of x you want to predict, so you will get 5, okay. um, Also, if you want to use Excel, there's a very good function called forecast. So forecast linear is a very helpful for linear interpolation, and also it can be used for extrapolation. So the syntax of this function, x, put the value of x you want to predict. You want give it, I mean non-value of x, and put the y is known, x known, so you can predict the value of x, of y, sorry. So now we have here x, y, all these values are known, given, okay. And suppose that you want to find, to interpolate 11.8. So 11.8 is between 10 and 12. So in order to use the forecast linear, then put the value you want to find the y value at it. So then choose the y nonce and x nonce. So then it will give you the value of y. So this is how to use forecast linear to predict the value of x. Now let's talk about regression. So what's regression? Regression is to find the best fit line between data, x, y data. So if you have like, let's back again. So let's say, yeah. So this is called regression. If you have a set of data between x and y, and this line represents the regression, and how much this line is fit to this data, okay? So okay, regression. So regression may be linear or polynomial, okay. For linear it has this equation, a dot a1 x, so this is a linear. And for polynomial, you can get different polynomial based on which order. So this is a second order polynomial, so it will be a dot plus a1x plus a2x squared. You can get mole polynomial. Yes, you can get mole polynomial for this one. So the maximum polynomial will be n minus 1. So how many n here? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Then you can reach to fifth order of polynomial. So here's a y will be a dot plus a1x plus a2x squared plus a3x cubed, and so on, okay. But for most of chemical analysis, okay, we use linear regression. So how can we determine the regression? Very easy, okay, using calculator, okay. So same screen we got last time. We've use mode and 3 to get this screen, okay, sorry, get this screen. And from this screen you can choose 2 to get linear equation. You will get this screen as well. Put your data using arrows and numbers, and don't forget again to press AC to make sure data is saved in the calculator. Then shift and 1 to get this screen, okay. Then go to full regression. This time we will choose A, B, and R. A is the value, choose A is the intercept, B is the slope, and R is the regression coefficient. Regression coefficient, how much data is very close to your to regression line, best fit, okay. So now regression. So we have two things. We have coefficient of determination and correlation coefficient. Both represent how much data are close to the regression line. If it's 1, that means it's perfect. If less than 1, that means they are far away from the regression. You have distributed data, and your line can't use to express your data. Okay. So how to present it? Using ST minus SR over ST. What is ST and SR? ST is the summation of squared deviation. Summation of squared deviation. And ST because it's used through Y. So now let's say you have X, you have Y, okay, and based on the coefficient of A and B, you have Y regression, okay, Y regression. Now, this Y, you have different Y, okay, different Y. So the average of Y, average value of Y, so the summation of Y divided by their number, so it's average. So Y true, this is the Y minus the Y average squared will give you the S deviation from the central value. Okay. Now we have Y regression. So Y regression, we used A and B to find Y regression. So how much these values are close to each other? Okay, regression and Y. So we summation of Y true minus Y regression squared. So you have to make all of them, then find the value of SR. And why we square them? This to eliminate the different of sign. For example, we use summation. So suppose that you have one difference positive 4 and the next value is negative 4. So it's huge. But when you make summation for them, it will give you 0. That means you don't have any error. So in order to cancel this effect, we make squared for plus and minus. Okay. So then we got squared SR and ST minus SR over ST. It will be the coefficient of determination, and its root will be the correlation coefficient. Okay, now suppose that you have an equation and this equation is not applicable in Excel. Okay, so Excel, you can't use Excel and you can't use calculator to find the function A and B. So you have, like for example, this equation, okay, and you know from your theory or from your review, the relation between y and x is this equation, a times x over p plus x. So how can you produce or find the regression of A and B? So you can find A and B using something called least squared method. So what's least squared method? Is mainly SR. Okay, we want to get minimum SR. If you get minimum SR, that means your value is correct. The regression, Y regression, is very close to Y true. So we how to make it? We use iteration, like guess values iteration method using Excel until find the minimum value. So we start by guessing a value of A and B and create our Y regression, okay, and create SR. And then we will ask the solver of Excel to change the value of A and B until get minimum SR. So the Excel will do a lot of iterations until minimizing the value. So you find the best fit model. Okay. So here we have X and Y, and let's see how we can apply it. Okay. Now this X and this Y, this is the initial values. Okay. And according to Y model, okay, Y model, A equal Y regression equal A times X over P plus X. So I created Y model or Y regression, okay, based on this equation. So I showed A, where is A and P? A and B, I just put any guess values, any guess, maybe 1, 1, 2, 2, anything, any guess values. So this will be, regression will be fixed value of A. Okay, I should make it fixed because when you change, okay, it should be keep the value as the same. So you can press F4. If you press F4, once you put your cell here and press F4, so this value will be fixed, times X, okay, divided by B. B should be fixed as well, plus X, and then fill the other cells as the same. So you get this value. As you can see here, there's a big difference between the Y true and Y regression. See, big difference, okay? That means these guess values are not correct, okay? And I used a wrong model. Then what I should do, since I have Y and Y model, I can build the SR, okay? So we have Y true and Y regression, minus them and take their summation. So I make squared for the difference between them, okay? So this is a summation, and then I can get the SR. SR is big value, 6.86, okay, based on the initial value. Now, so now I can use solver in Excel and ask the solver to make this value as minimum value by changing this value. So the Excel will do iteration until reach the minimum value. So how to make it? From data, okay, you can go for data, you will find solver, okay? When you choose solver, okay, then this window will appear. Now you have a set value. So what is the set value? This value I want to set. So you have three options: maximum, minimum, or value of. So I will choose minimum value. Okay, by changing of cells, which cells you want to change? These cells, 1 and 2, these cells. So A and B. So then press solve. Then so the solver will make iteration until make this value will be final, and it will be give you the final results of A and B, and will ask you, do you approve it or not? Okay, so by this we finish our this part for statistic, and see you in next part inshallah soon. Thank you. Assalamu alaikum wa rahmatullah.